first I need to print the names. Example should be more, I don't know what. So the lambda expression you can use with any collection, not with any collection, with any methods, okay? With any built-in methods, like select, like find all, find index of whatever, okay? I'm shocked why this example not work. Okay, this is the second example. I created class. This class with setter and getter method. Okay, this setter and getter method add value or assign values for ID and names. Okay, the ID is integer and names is string. Okay, without declaration variables, without declaration attributes, the compiler will understand this ID, okay, attribute, because return integer. Also, the name will return string. So the name also attribute. Now here I create list of student for winter semester. Added this list set of objects. You see. Now I need just to print the names. We don't need to print the ID. Okay, inside I create names, variable names, public names. Okay, I'm sorry, public collection. Inside these names, I select all names from objects. Okay, then print the names. Okay, now run the code. Yes. The first console write. Console write just to separate two lines. Right line. Okay. ST plus with space. Run the code again. You see, John. Oh, blank. Okay. Also, please try this code. Create internal class student, you see. With ID and names. Create list of student. Create public list or public variable, public collection to be more accurate. Public collection and select items, select the name of the object. Okay, select just the name. Okay, dot name, we call this method name. Okay, and return the name from object. Console to write line. for each string, because the names here are string. So string item st inside the names, and console.write the st. It's clear, guys? It's clear? Okay. Student. It's okay. Clear? Okay, statement lambda consists of the input and set of statement not to be executed. Okay, input, the lambda notation equal greater, and the statement between curly brackets. Okay, guys, go back to the generic concepts. It has introduced the concepts of type of parameters, which allow you to design a class, and methods that defer the specification of one or more types until the class or method is declared. As we said, the type parameter is placeholder. Okay. Generics are most often used in conjunction with collection and methods that operate on them, which brings some benefits such as improving code reusability and ensuring type safety. You remember the last example when we declared three arrays. So by using genetic data type, we can pass many data types to for example, to methods, or class, or interface, or struct. So the main concept of generic, how to reduce the redundant of code. Okay, the importance of concept generics, guys. The first reason. Okay, data was described by strictly defined types such as int, float, double, or other pairs of these types. Also, we can create a collection of this data type, like array, structures, classes, lists, whatever. The need to create the same element for different types, okay, give rise to the redundancy of the code. Second reason, to improve the type safety when using non-generic collection. In this kind of collection pairs, array list, hash table, sorted list, and others. Okay, when extracting data from collection, you must explicitly specify the type conversation. casting, constant conversation, or I'm sorry, convert whatever to double to integer. Okay. To avoid this, you need to add it. Okay. In this case, maybe will run an error. Okay. So to avoid this, you need to add additional flux for of checks using the try and catch. You remember try and catch flux? Okay. This is the exceptions. Boxing and inboxing. Boxing and inboxing is technique to convert between reference data type and object, between reference data type and the primitive data type. Boxing, like int I equal 5, okay, create an int value. It's a primitive data type. Also object 1, we casting the I to object. That's mean explicitly box the int value. Convert int value to object. Unboxing, okay, it's different. It's convert from object to integer or primitive data type, like you see integer int1 equal casting int for the object. You see, guys, this is the primitive data type. Okay, primitive data type when declare int I equal 100. Okay. The I, the I reference to not reference, that include or that we make a space in the memory and put 100 inside it. Okay, this space, okay, has an address. Okay, this space has address. In reference data type, it's different. Okay, we create a pointer, and this pointer reference to what? To the space where is the value located. Benefits of using generics. Using generics provide the following benefits. Okay, simplifying the code, program code. Using generics allows you to implement the algorithms for any types of elements. Okay, in some coding, the algorithms maybe some if you work in the research, for example, maybe your professor or your supervisor asks you, I need to do something, build algorithm to do something. Okay, this algorithm usually consists more than 1,000 line of code. Okay, it assumes we need this algorithm to work with different data types. So in each time, if you want to deal with different data type, in each time you need to declare this algorithm again. Okay. For example, to deal with integer. For example, to deal with the string, whatever, double, float. So by using generic algorithm, okay, we remove or we avoid this problem. Okay. To simplify the code, ensuring typical safety. When you pass value, you ensure that this value will be processed correctly and return the value or return the desirable value. In generalization, the need for explicit type conversation when converting an object or other type of process data is eliminated. Productivity increase, productivity of your program, your software. Okay, where we can use a generics, you can use instruct, class, interface, delegate. Okay, delegate what I was talking today. Okay, the delegate, how to convert the anonymous methods to delegate keyword. Okay. Also, we can use a method like the last example, dealing with array. You remember this example? Okay. We declare 3 arrays, integer double string. So just we need to make, this is the structure. Okay, guys, this is the structure. Okay, guys, this is the structure for, I'm sorry, of method, generate method. This generate method, okay? Just the same name, the same declaration, but before the arguments, declare your generic data type, for example, T, any name, okay? Any name, T, any name. It's not important, okay? And the parameters should be like this data type, okay? Now, when I pass integer, this method will work with this array. When I pass double, okay, this method will work with double. When I pass string, also this code, okay, will work with the string. Okay, generics are not limited to class. We can use in struct, we can use in delegate, we can use in method. The application of generic to collection is highlighted. A number of generic collections have been created. Okay, whatever list, array, dictionary. If a language element, class, structure, interface, method, delegate operates with parameterized data type generalization, then this element is called generalized class, generalized method. Okay, like this example. Okay, this is generalized method. This second example. Okay, public static void display. Please try this code. Take a break or leave early? No, it's up to you. Huh? Okay. This is example of generic method. Now public static void display T. T, your data type, your generic data type. Okay. This method take one argument, one parameter, T of O.
T of O, what is so O?
Professor, for the second slide, the display, you had to specify that it was a double. Can I ask why that is?
Okay. Thank you. That's what I'm looking from somebody to ask me why we did this. Okay, guys, and the method, as I said, generic method. We pass one parameter. This parameter from type T. Type T is generic data type. Inside this parameter, inside this method, console.writeLine or .getType. What is the meaning of getType?
Returns a type.
Type, data type. What is the type? What is the data type? Okay. The second one, convert any item, I'm sorry, any parameter to string and print it. Okay. Now inside the public static void main, I pass the first item, the first parameter, integer data type equal 5. Okay. So the first statement will return for us system.int. Okay, system.int. The second, print I as is, as string 5. Also for double, we'll print system.double and return or print 905. Okay, the string the same, system.string, or system.string, and print the APS. Okay, double. Here, okay, I force the method to deal with this, with D, as a double, not as a generic. Okay? This is the difference. H is object. So we'll print .get type system.object, also to string system.object. This is the output. Yeah, this is the output. I'm sorry, not system. Okay, your namespace, because hello belong to what? To your namespace, your project. Okay, console app 2.hello. Okay, and the print also console app 2.hello. guys, it is not mandatory to use just one generic data type. I can use many generic data type. I can, for example, inside the practice, I can, for example, write U, comma, T. Okay?
But doesn't that imply that there's only one data type being used? So just U, does, like, say they use like value 1 is a string.
Do you
value
know?
is-
Do you know what will happen if I declare two data type Y and T?
Mhm.
Y will never be equal with T, and this and also the T will never equal with Y. I mean, inside this method, I need to work with Y and T separately. Okay. There is no of one related to other. Okay. You remember reference? Reference. I taught this topic in the programming one. Okay, guys, reference. Reference keyword and out keyword. Reference keyword, I need from this method, okay, pass the parameter as is and return the same parameters. Reference. So I still use XY after calling. I pass parameters, return the same parameters after make some processing in these parameters. Okay, and return with a new value or the same value. That depends on the method, the functionality of method. What about out keyword? The simple difference between reference and out. The same functionality, but the out keyword, okay, out. Okay, you should change here and here. Okay, out I can pass null value. Okay, I can pass variables with null value like int x, comma. Sorry, semicolon. Int y, semicolon. I can pass this value. Okay, but I have to what? I have to assign for this value. Okay, inside what? Inside method. And return. You see, there is no return value. Okay? There is no return value. You see? Reference. Okay? Reduce this statement. Reference like I create, this is X, this is Y. Ref, like reference data type, okay? But indicating what? In X. Reference ref, okay, indicate, or reference to Y. Now take this arguments, okay, and make your calculation inside this method, but still, okay, still X, I'm sorry, X,
Still
or
retains
this,
the value.
this reference, I'm sorry, this reference is still, okay, reference to X, and this reference still reference to Y. And print those attributes, okay, with a new value. And out, the same thing, but with null value. With null value, but I have to okay, assign value inside the method. The both without return statement. Do you know what other benefits? This replaced by two return statements. Usually I can't use more than one return statement, right, inside the method. Yeah? So by using this, okay, like I said at the end of the method, return X and return Y. But with void method, you see, void method, no return data. Now what is the output? What is the result of X and Y? This method the functionality of this method makes swap, okay, between value 1 and value 2. I create the first variable with the same data type U, okay, assign value 1 to temp, then assign value 2 to value 1, and temp to value 2. Make swap between variables. The return X and Y. Now, in the first statement, print before calling this method. Okay, so the system.console.writeLine will print, okay, X as is, Y equal 3 and X equal 5. Now, in the after make a swapping between X and Y, okay, print the statement X and Y, X equal 3 and Y equal 5. This is the output. The last example of generic methods. You see, what's your name?
Arna?
Arna.
Yeah.
You see, I declare two generic data type,
Yeah.
T and Y. But inside the method, I cannot make any relationship between T and Y, T and Y. Like integer double, like integer string.
Yeah.
Okay? Now inside this method, make print for I pass array and variable from data type U. For each, making for each loop and print the elements for this array. And at the end, print the calling for str. you write, for example, here, element equal str, okay, the compiler will underline this statement as wrong, okay, with red color line. Now inside the main method, we have integer, double, char, array. I pass the both, all of them. Okay, you see, in the first I pass int array with a string item, with a string variable. In the second, I pass double array with double value. Okay. In the third, I pass character array with character. So the output array int array contains 1, 2, 3, 4, 5. Calling for int array. Okay. Array double array contains those values, and the calling for 9.0. Int array character array contains the characters hello. And the last, the calling for C. So I can declare many generic data type, okay? How I can decide how many of generic data type? That depends. What is the problem? Guys, the last example. Please try this code. Create a class method. Create a class unit with those attributes and added methods. Okay. This is a generic method. Calculate the similarity between two objects. Inside the main method, create two objects and print the calculate similarity. And let me see the result. Sorry. Equals method return a Boolean value true or false.
True.
Hmm? The result true
Yeah.
for the ST1 and
Oh, are
ST.
you okay, I'm sorry. I thought you were talking about the method in general.
No,
No, not for these two objects.
Yeah. Equals the same in the string. The method is already included with the string. We can, for example, declare string as string. Okay. For example, s, and you can call this method s dot equal. Equal with what? With another string. Okay, the battery is running low. So on the time. Okay, the return value will be false. Thank you guys.
So next week we're gonna do the week 2 stuff.
I'm sorry?
Next week we're gonna do the week 2 stuff, this next.
Yes, we will complete this week. No. We will complete this chapter. This chapter we will learn extension methods. Okay. Also we will explain the delegate method.
The lab is not for the next week.
Yeah?
The lab is not for the next week.
No, I think the next week. After the next week. In the end of the next week. Okay?
Can you see the labs already?
No, that's my concern.
No, it's not a very
Right.
we complete the concepts of classes, just to review for different concepts of class, structure, data structure. Because you know, the data structure, it's highly related, it's highly dependent on the classes, okay? How do you declare class, how I can make class reference to another class, okay? I will show many examples, start, queue, linked list. The class is reference data type, right? So I can create set of object. Each object has attribute of reference. For example, next and back. The same, back, next. Next and back, reference data type. You declare a class somewhere called node. Okay. Next is node. It's not a class. Back is node also. Node. Node. The value of next and back. Okay, the value of next and back is object. Then this object has attribute. Also two of them, okay, two of them pointers, next and back. Next indicate or reference, I'm sorry, to the next object, okay, and so on, to next object. Back, you can assign value to the previous object. Also here, the previous object. Without back, linked list, called linked list, one way. With back, with back, circle linked list. Next classes, it's easier from generic. It's easier than generic. You will, the next class, we'll complete this chapter. We still we need to learn the generic methods. Generic classes. This is an example of generic class. This is a class with T, generic data type. Inside this class, I declare data T, attribute from generic data type. Okay, and declare the method to deal with generic data type by T. So when I declare this, when I declare object from this class, okay, I replace any value by T. So I can pass integer data type, I can pass double, I can. Also this example about generic class, generic interface, yes, type of constraints. Also we'll take type of constraints. This class I want comparable with data type, but should this data type, for example, the same same data type. The class is data type. Okay, remember that. The class is data type, but your data type. Because you built this class, you built this data. Okay guys, thank you. It's enough. You can leave.